Okay, I'm going to record this video in two parts. One is the math part of it, and then we're going to do the calculator portion. I'm going to do it in shorter videos just to make sure everything's recording correctly. I know I'm having problems with some choppiness. Let's see, I think I've got it fixed, though. Okay, just in general, we're working on the AP questions. These are going to be the multiple choice, not the multiple choice, the free response calculator ones, because that's probably the ones they're going to give you. And we're going to do the most typical ones first. And the first thing I want you to know is that when we integrate rates, we get quantities. And when we derivate quantities, we get rates. So, for example, if I integrate meters per second, I get meters. If I derivate meters, I get meters per second. And a lot of the problems are going to have that, and then what's going to happen is there's going to be equations, and you're going to have to decide whether you're going to integrate them or derivate them. And sometimes what you think you might have to do, you might have to look a step deeper on the AP problems. So let's take a look at the first one here. It says fish enter a lake at a rate modeled by this equation. So this is fish entering are following this rate right here. That equation is for a rate. So E of t is a rate. Just write down R so I know. Fish leave the lake at a rate modeled by L of t. Once again, this equation is a rate. And they'll usually give me the units of measure. That means E of t is measured in fish per hour. That means the integral of fish per hour would end up being fish. So if I want the number of fish, I'm going to be integrating this equation. First part it says to do is how many fish enter the lake over a 5-hour period between 0 and 5. Give your answer to the nearest whole number. So what I've done is I set the integral from 0 to 5 of that particular function. We'll do it in the calculator a little bit. I also rewrote it this way. You can write it like this as long as you make this initial statement at the top right here. Either way is fine. We're going to get an answer for those right there. Question B says, what is the average? Oh, and as soon as I see average, I know it's going to be one of two things. It's going to be the average value of a function or average slope. So what I'm going to look for is what are they asking me for? What is the average number of fish? They want the total number of fish. They don't want a rate. They want an average value. And the average value is going to be the integral of a function from its start to its finish divided by how much distance was covered. So I've written that down over here in two possible formats. Notice we're just deciding whether we're integrating or derivating. And here we're going to integrate from 0 to 5. That's going to give us the total number of fish in that interval. Divide by 5. It'll tell us the average number of fish coming out at any point in time. Okay, so see, as these problems go, they end up getting a little trickier as you're going. So you kind of figure out what you're looking for along the way. It says at what time for t equals 0 to t equals 8 is the greatest number of fish in the lake? Justify your answer. So they want to know when the most fish are there. What's true about when something is at the most? Well, then the rate of those things is equal to 0, because that would be a turning point. So wherever the rate is 0, so wherever the rate of change of fish is going to be 0. Well, I know that the number of fish is the integral of the fish going in minus the fish going out. I might be overthinking this, but I'll show you what happens here. The rate of change of those fish is going to be the derivative of the integral of those things, or these two things cancel each other out, which makes sense. We know that E and L are rates. I'm going to find when the rates of the fish coming in minus the fish coming out are equal to 0. I'll look at the graph, and then I should have enough info to solve it from there. And then part D says, is the rate of change in the number of fish increasing or decreasing? When I want to know about something increasing or decreasing, I want to look at its rate of change. So to see if the rate of change is increasing, I'm going to look at the rate of change of E minus L. And that would be E prime minus L prime. If it's positive, it's increasing. If it's negative, it's decreasing. All of these answers can be found using the calculator, and we're going to do that in the second video. I will save this one, make sure it works right, and then we'll show you the solutions to this problem using the calculator.